Welcome to my channel PSP Protect. Today we are going to discuss how to test Micom P643 relay using an Omicron relay test kit. We are using CMC 356 relay test kit. Now you can see the various settings which we have uploaded in the relay. During this testing, we are going to verify whether the set parameters which we have uploaded in the relay are same as the operating parameter of the relay. Now testing is basically to verify whether the relay is working or is operating according to the set parameters or not. While testing a differential relay, we need 6 current channels, 3 for HV side and 3 for LV side. So here you can see that we are changing the hardware configuration of the Omicron relay test kit using the Test Universe software, where we must select IL1, IL2 and IL3 for HV side and IL1-1, IL2-2 and IL3-3 for LV side. Now another thing to keep in mind is when HV side we are using phase angle of 0 degree, minus 120 degree and 120 degree, then in case of LV side we must give a phase shift of 180 degree and then use the balance angle so that accordingly other phase will also get a phase shift of 180 degree. Now, the first test will be measurement and stability. For that, we need to calculate the secondary side full load current. And as per the calculation, the full load current in this case is 2.270 ampere for HV side and 4.360 ampere for LV side. So we are going to first put these values on the HV and LV side and we will measure whether the same current, same full load current is being shown by the relay, in the screen of the relay, and as well as we are going to um, input that value through the measurement module of the Micom relay. And here you can see we need to first configure the measurement module so that we can see the actual current value which the relay is reading while we are injecting current through Omicron relay test kit. That value of current can be visible in our laptop screen also using the measurement module of Micom relays. As we configure the measurement module, you can find all the various current values per phase as well as the phase angle values. We can also get the differential current, restraining current, and the second harmonics, fifth harmonics, differential current, restraining current, all the various data which we need during the testing. And then we will inject first full load current 1 into FLC to both HV as well as LV in phase opposition, and we can find that the I bias or the bias current is 1 pu, that means 1 into FLC current is injected, and then we will do it for 1.2 times, that is the 1.2 times current on HV as well as 1.2 times current on LV will be injected, and we can see the bias current will then become 1.2 pu, while when balanced current are injected on both the side for measurement and stability testing, then differential current will be zero. There will be no increase in differential current for, which usually going to give the tripping during the unbalanced current. As I am going to show the complete process of differential relay testing, so here in this video is going to become a bit lengthy, as we need to do a bit of calculations, and then we need to verify that the relay is operating according to those calculations. So next, you can see we need to do some basic calculation, that is to derive the full load current of the transformer in which the differential relay is installed. And according to the primary side full load current, the secondary side full load current will also be calculated. And along with that, from the secondary side full load current, we are going to calculate the pickup current, that is 20% of the full load current, which is as per the setting which we have shown earlier in this video. And next we will show you that by injecting this three-phase pickup current, how the relay is going to get is going to give the tripping on differential current. And we will perform the three-phase pickup as well as the single-phase pickup. Now generally the single-phase pickup is 1.5 times the three-phase pickup. So we will calculate the three-phase current. As you can see, in this case the three-phase pickup current is as follows. Now the next test is pickup test for differential relay. So in pickup test, first of all we are going to show the three-phase pickup test for HV side. So as per the calculation you have seen, the pickup current should be around 454 milliampere, that is 20% of 2.27 ampere. Now we will gradually increase the current, as you can see, and you will find that the differential current in three phase differential current is also increasing as we increase the current on the HV side, and we'll keep the LV side 0. So the differential current will be completely the HV side current, and as you can see, as we gradually increase, so the differential current is also increasing. and now the relay gave tripping on 460 milliampere. Therefore, the test is okay for the relay. Next, similar way, we are going to inject the three-phase pickup current on the LV side. For LV side, it is around 872 milliampere as per calculation you have seen. So gradually we will increase the current here also, and we will keep the HV side current 0, so that the differential current will be completely the LV side current. So as you can see, the relay tripped on 860 milliampere, and therefore this test is also found okay. Now, after three-phase pickup, we are going to perform single-phase pickup test for the relay. In case of single-phase pickup test, only in one phase the current will be injected for all the 6 current channels, and others will be kept at 0. So first of all, we are going to inject it for R phase of HV side. Now, as you have seen earlier, that for the R phase, for the HV side, the three-phase pickup current was around 460 milliampere. So, if we consider 1.5 times of 460 milliampere, that is going to come around 690 milliampere. So, let's see at what current the single phase pickup takes place in this relay. So we will gradually increase the current from 650 milliampere, and where you can see that uh, it comes on at 680 milliampere. At 680 milliampere, the tripping is observed, and you can also see that only the R phase differential current is increasing. The other differential current is not increasing, is not increasing. So only R phase is increasing, and this test, per phase pickup test, basically show us that the per phase tripping element of the relay is working properly, as well as the per phase differential tripping on the per phase differential tripping indication on the relay, that is through the LEDs, is also being working properly. I cannot show you the relay tripping on the fascia of the relay, but as the R phase differential is operating, only the R phase LED is going to come. As the B phase tripping occurs, only the B phase LED is going to glow up. So in this way, we are going to test each and every part of the relay, so that while the relay is in operation, it works in a proper manner. Now, similarly, we are going to inject the single phase current in the pickup current in the LV side also. Now, as the LV side three phase pickup current was 860 milliampere, if we multiply it with 1.2, 1.5 times, then it comes 1.290 ampere. So we are going to put a little below this amount of current, and we will see how the tripping is observed at what value. So let's slowly increase the current from 1.275 or 1.260, anything which is below 1.290. Now you can see that the tripping is observed at 1.278. So, which is as per the permitted errors, as per permissible value, which is within the permissible limit. So in this way, we can check the per phase pickup current in differential relay. Then the next test which comes is a very important test for differential relay, which is the slope test. Now, in case of all differential relays, there are all differential relays have a characteristic curve according to which the differential relay operates. As we have seen earlier in this video that the characteristic curve starts with zero point 0.2 pickup current, then it's having a slope of 30%, and which is having a breakpoint at 3 pu, and above 3 pu the slope is 50%. So this slope of the characteristic curve will be tested here in this video. To start the testing of slope, that is the 30% slope or the slope 1, we can use either a single point method or a double point method. Though slope 1 can be obtained through single point method, but we are going to use a double point method because it gives more accurate result. Double point method means we will take we will get two tripping points and having two differential current and two restraining current. Each tripping point will give one differential current and one restraining current, and we will put that 2 points in a formula to get the slope as shown in the later part of this video. So first of all, we will apply 1 into FLC. 1 multiplied full load current. So will be applied on both HV as well as the LV side. And then the value of the HV side will be increased to find where the tripping occurs. We will first gradually increase it and then increase it in the multiple of 100 milliampere, but later on we will reduce that difference and to get a more accurate point of tripping. So as you can see that when we are applying the first 1 into FLC current, then we are getting the first tripping on changing the HV side current. We are getting the value of 0.720 0.352 differential current and 1.198 restraining current. And in the similar way, then to get the next tripping point on the 30% slope, we will apply 2 into FLC current, means 2 times the full load current on HV side as well as LV side, and similarly we will increase the current on the HV side. As we increase the current on the HV side, it gives a tripping at 0.720 differential current and 2.404 restraining current. Now when we apply subtraction of the ID2 minus ID1 divided by IB2 minus IB1, the restraining current, we will get the value of 30.51%. So as we have shown earlier in the earlier part of this video that the first slope is 30%. So we are getting 30.51%. In the similar way, we will test for slope 2. Now slope 2 is above 3 pu and its value is 50%. So to get the slope 2, we will again use the 2-point method, and first point of tripping we will apply 3 into FLC because the slope 2 will come when the biasing current is above 3 times the FLC. So we will apply 3 times the biasing current on 3 times the full load current on HV side as well as on the LV side, and gradually we will increase the HV side current. You can do it for both HV side current as well as LV side current, but as the LV side current is smaller than the HV side current, so we prefer to increase the HV side current, which is actually beneficial for the Omicron test kit because it does not need to supply the higher amount of current. So as we are increasing the current slowly, applying 3 into FLC, we will get the first point of tripping in the 50% slope. And let's see what is the value of the slope actually comes. So as you can see that the first point of tripping with 3 into FLC, the differential current comes as 1.220 and the restraining current comes as 3.670. And in the similar way, we are going to apply 4 into FLC, 4 times the full load current for the second point of the slope 2, and where the differential current at the time of tripping, the differential current comes at 1.903 and restraining current is 5.034. So we get a second slope at 50.07%. So in both slope 1 and slope 2 we have seen that the actual operational slope is as per the slope settings we have uploaded. In this way it is the best way to get the slope of all differential relays, but we can also do it in the Omicron relay test kit using the characteristic curve method also. I have shown it in the later part of this video how to test the differential relay slope using the characteristic curve. In that case, we need a feedback from the relay to stop the kit. Here we are stopping the kit manually at the time of as the tripping occurs. The next testing is harmonics. All differential relays do have a harmonics restraining capability which restrains second harmonics and fifth harmonics. All these harmonics get generated in transformer at the time of switching it on. So it is very important to restrain these harmonics, and therefore we will also test that what is the value of the harmonics at which till which it is restraining. As per as per our requirement, we used to give 15% harmonic setting for second harmonics and 35% setting for fifth harmonics, as we have shown in the earlier part where the settings of the relay is shown. Now to test the harmonics, we need to apply the full load current on both HV and LV, and suppose we want to change the HV side current, want to reduce the HV side current, then the HV side frequency will be made for second harmonics. It need to be made 2 into 2 times the nominal frequency, that is 50 Hz. So we will apply 100 Hz for HV side and LV side we will keep it at 50 Hz. Now as we reduce the current on the LV side, we are going to get tripping at around 0.380 ampere or 380 milliampere against the full load current 2.270 which is applied. So 0.380 by 2.270, that is 16.74% is the second harmonics we are getting. Similarly, to test the fifth harmonics, we need to first apply the full load current on HV and LV side, and we are going to reduce the HV side current. So we need to change the frequency of HV side to 5 times the nominal frequency, that is 250 Hz, and LV side frequency will be kept at 50 Hz. So that is, we are creating a harmonics, a situation of harmonics or fifth harmonics, and then we need to reduce the LV side current to get the differential tripping. So we will find that at what current the tripping occurs. Now the tripping occurs at 0.770 ampere or 770 milliampere against the 2.270 ampere applied at the beginning. So which is giving a percentage of 33.92% against the 35% setting. So this is also within permissible limit. Now this is another process in which we can test the differential slope characteristic using differential operating characteristic curve method. Here we don't need to calculate the slope, we just need to get the file from the differential relay, the X-ray file from the differential relay, and we need to upload it in this module of differential characteristic operating characteristic test module in test universe. The process of uploading the X-ray file in this module has been shown in one of the earlier videos. You can check it out in this channel where it is shown that how various characteristic curve can be obtained and uploaded in the test universe to do the testing of distance relay or differential relay. Now we are uploading the X-ray file in this differential operating characteristic module, test module, and you can see that we will get all the various details of the relay in this test module once it is uploaded. That is, we are going to get the pickup current, the slope 1 setting, slope 2 setting, breakpoint setting, harmonic setting. Everything will be available through the X-ray file, and then we just need to choose the point on which we want to conduct the test. As here you can see all the settings we got on the test universe test module. This is a easy method of doing the slope test, but you need to first download the XREO file from the relay and then upload it here. Here you can see we are having the characteristic curve of the relay as shown, and now just we need to put the points, various points at which we want to test. Now here the breakpoints will be easily visible, so the how the characteristic curve is there in the relay, that could be visually understood in a detailed manner in this characteristic curve. It can be understood well in this curve that where the 20% pickup current is there, and after which point we get the 30% curve, and after which breakpoint we get the 70% curve. It is easily visible in this characteristic curve, and we will just put various point to test, and we need to get a feedback, binary feedback from the relay, and we need to just start the test, and one by one all the result will be available on this curve. The next very important test is the overflux test of the differential relay. Overflux, alarm and tripping, two options are available in all differential relay, and overfluxing is very important part in transformer. So to give overflux protection, we generally use the overflux element where the voltage to frequency ratio is observed. As the frequency is constant at 50 Hz, as the voltage increases, we get the tripping. First, alarm is there for 5 seconds and then tripping occurs at certain value of overflux tripping. So here in this relay, we are having the overflux alarm set at 2.4 and we are getting it at 2.425, and the overflux trip is at 2.53, we are getting it at 2.529. Thanks for watching this video. I will come up very soon with some other video. Thank you.